Okay, so we want to find and classify all points of inflection for this function here. Okay, so to find the points of inflection, you need the second derivative. So you're going to need to get the first derivative, which is 4x cubed minus 12x squared. Okay, and therefore the second derivative is going to be 12x squared minus 24x. Okay, now let's factorise this. Take out 12x as a common factor. It leaves me with x minus 2 inside the brackets. Okay, so we need to get a sign diagram of the second derivative. So sign diagram is going to look something like this. If I made x 0, this whole thing becomes 0, the second derivative becomes 0, so 0 is a critical value. And then if I made x positive 2, the second derivative becomes 0, so therefore 2 is a critical value. Okay, now subbing, let's sub 1 into here, it'd be 12 times negative 1, so it's a negative answer. If I subbed in negative 1, it'd be negative 12 times a negative answer, which is positive. And then this would be positive if I sub the number greater than 2. So what this tells me, tells me the shape of the function is concave up here and concave up after 2, and it's concave down in between 0 and 2. Okay. Also, because the signs are changing about these values, these are points of inflection. Okay, because the signs are changing, these are points of inflection. So I know I've got a point of inflection at x equals 0 and a point of inflection at x equals 2. Alright, so I need to get the y value, so I do f of 0, I sub it into the original function, so it's going to be 0 to the power 4 minus 4 times 0 cubed plus 5, so f of 0 gives me 5, so I know there's a point of inflection at 0, 5, and then I do f of 2, it's going to be 2 to the power 4 minus 4 times 2 cubed plus 5. That is going to give me an answer of negative 11, so I know the other point of inflection is at 2, negative 11. Now, I don't know yet whether they're horizontal or non-horizontal points of inflection. Here's how I do it. I sub them into the first derivative, and when I sub them in, if I sub in 0 and the first derivative gives me an answer of 0, it's horizontal. If it doesn't give me an answer of 0, it's non-horizontal. Okay? Same if I sub in 2. If I sub it into here, it gives me an answer of 0, it's horizontal. If it doesn't give me 0, it's non-horizontal. So what I do is I sub 0 into the first derivative. So that's going to be 4 times 0 cubed minus 12 times 0 squared. You can see that gives me an answer of 0. So therefore, this point here, okay, is a horizontal point of inflection, okay, because the first derivative equals 0. Now, sub in x of 2 into the first derivative, and that's going to be 4 times 2 cubed minus 12 times 2 squared. Okay, that is going to give me an that's 32, take 48. Well, you can see this is not 0. Okay, alright, it's negative whatever, 16. So therefore, this is non-horizontal. Alright, because it does not equal 0. So I have a horizontal point of inflection, at 0, 5, and a non-horizontal point of inflection at 2, negative 11.